Okay, good morning, everybody. Today is the 16th. Hey, is it Friday? Cool. Not that it really means that much anymore, huh? 10:16. Okay, so today what I want to talk about is graphing these polynomials, so, and all their different characteristics. So graphing polynomials. And we're going to make it pretty easy because we're going to let the calculator do a lot of it. And again, if you have Desmos on your phone or on a computer, it's really going to help. If you don't have Desmos, then that's going to put you at a bit of a disadvantage for sure. But let's take a look at it. So first of all, local min or local max. Okay, so that's basically top of a hill. I know that's not very mathematical, but it really makes sense. Top of a hill, and then a local minimum is the bottom of a hill. And the reason we say it's local, give a really easy example, just draw a little graph here. I'll draw a little graph so it makes sense. Is you could have a graph like this. And you call it a local max because if the graph keeps going forever up, there's a lot more higher points, right? So that's why you got to call it a local, because the absolute max is at infinity. Local min, right here, but again, you have to call it a local min because there's an awful lot of points a lot lower than that particular point. So local min, local max, just the top of the hill. There's my local max, there's my local minimum. Now the inflection point is where you change from concave down to concave up. Okay, let me show you. Or vice versa. Or other way around. Or down to up. Or up to down. Up to down. I'll show you what I mean. So, watch. Here is what we call concave down. Caves is like a curve down, okay? And then right about here, right about there, it changes. Okay, cups down, and then all of a sudden it changes to cupping up. So I say like a roller coaster ride, okay? If you're hitting a roller coaster ride, you're going up and up and up and up, you start to accelerate, you go whee, and then right about here, you start to go back up, you start to whoop up again, okay? So that's my inflection point, concave down to concave up, or if my graph were upside down, you can say the way I'm going concave down to concave up, okay? That's my inflection point, okay? Now, let's graph. Now, before I do a whole lot of graphing, there's a few things I know. I do know that I'm going to have zeros at -3. I know that without even using my calculator. And I'm going to have zeros at 2 twice. Okay, 2 twice. Now we call that a double root. So to be a double root, it means it's got to go through it twice. Well, let's put down the -3, 2, 3. That's there. Now, 1, 2. Okay, now it's got to go through this twice. So my graph is going to look something like this, okay? It's going to go up through here. And then it's got to go through here twice. How does it go through twice? Well, it goes through it just barely, like hardly any, goes through it and back up again. So in a sense, it goes through it twice at the same spot, okay? Now, if we were to go ahead and graph that, I'm pretty sure I'm right on this. Well, not even pretty sure, I know I'm right on this. I can use my Desmos again. My Desmos. And I can graph in my 1/6. 1 divided by 6. Move it over. Okay. Up, hold on, clear. Okay, 1/6, move it over. Parentheses. And then parentheses x plus 3. Parentheses. Parentheses x minus 2. parentheses squared. Okay, there it is. Okay, now I didn't have a very accurate graph of it, but I do see my double root right there. See my double root? Happens at 2 twice. And if I wanted to get a better graph of it, I can actually go ahead and get my minimum then. Oh, I have it a little bit backwards, but that's okay. We'll fix it, okay? Oh yeah, because it is going to be, that's it. Okay, so I had it backwards. Good thing I checked it on my phone, huh? So I'm going to have a point, and that's also why I drew it lightly. Okay, so let's see. Let's fix this now. So let's go to a minimum of -2. 1, 2, 3, 4, 5.3. There's my minimum at -2, -5.3. I'm going to have, there's my 0. I knew that. My other zero's at 0. Go through here. Oh, hold on. There we go. Shoot. Anyway, got it right. I had an X in there. Now my graph looks better. There's no graph there. There's no point there. There's my maximum at -1.3 and 1, 2, 3. Boy, see, I was good. Dang it. I was right. I should have trusted myself. 1.3 comma 3.1. That's my maximum. And my minimum is at my 0.2. My inflection point seems to be right about there at the 0.20, which I don't have that one graphed very good. There's my inflection point at 2.0. Okay, so let's write them down. Okay, those are my zeros. My maximum is at -1.3 comma 3.1. My minimum is at 0.2, and my inflection point is right where it changes. My inflection point is at the point 0.2. Okay. Again, I'm just letting my calculator do the work. Obviously, because I had it right, but then my calculator made it more correct. Okay, so all right, that's not so bad. Okay, now let's take a look at this one. Okay, so same thing. Let's find the x, y intercepts, local max, local min, and an inflection point. Let's just let the calculator do it. Now I don't know what the zeros are. I would have to graph it to get my zeros or factor it. Doesn't look like it's going to factor. That does not look like it's going to factor at all. So let's go through and just put in my calculator. So 6x, and hopefully I won't make a dumb mistake, cubed plus 5x squared subtract 17x subtract 6, and there it is. So zeros, let's see, let's just tap on them. There's 1 0 and 1 0, so zeros. I've got 1 0, and I know it's a 0 because of the 0. See the 0 for the y value is at negative, well, it's -1/3. I know that decimal. Okay, where's my other 0? At -2 and where's my third 0? At 1.5 0. So this thing probably would factor, but it just doesn't look like it's easy to factor. We don't need to factor it because we have our calculator. So my minimum, let's see my minimum. Tap on my minimum. I love it. My minimum's at a 0.73 comma -13.4. That's my minimum. My maximum, I'm going to tap on that, and I get a maximum at a -1.29 comma 11.37. Okay, so my inflection point looks like it's right there in the middle. See how I'm going curving down, and right about here it looks like it curves up. So my inflection point looks like it's going to be really at but here's what I know. It's got to be in between. It's got to be halfway between these two. My inflection point is got to be in between these two, so let's check the height. So it's probably down here more. It's probably more right about there. Okay, so let's go ahead and graph this. Okay, so zeros. Okay, negative 1/3 is about there. Put this in red. Negative 2, 1, 2, and 1.5. I might have to go by 2's on my y-axis to make them fit. 2, 4, 6, 8, 10, 12, 14, negative 2, negative 4, negative 6, negative 8, negative 10. So let's graph these. I've got 0, 0, 0. I've got my minimum at 0.73 and negative 13. So I'm going to go 2, 4, 6, 8, 10, 12, 13 is about there. My maximum is about 1.3 and about 11. 2, 4, 6, 8, 10. 11 is about here. Okay, so we just sketch it in. And there we go. Now my guess is my inflection point's right about there, because it's got to be halfway between the two. Okay, and in calculus someday you're going to find out how to find this inflection point. Okay, all right. Anyway, there it is. Homework's out of the journal. Go ahead and use your calculators or your Desmos if you need to. Okay, there you go.